At times, designing successful new applications for powder metallurgy can seem like walking a tightrope. You start out on solid ground, sure-footed in the knowledge of what your technology is capable of. But to get to the other side, you have to traverse a chasm of unknowns. You must be able to accept the risk involved, attempting to achieve something you haven't done before, with no guarantee that it will succeed. You know that it will call upon your ability to strike a delicate balance between a host of factors, like the choice of material, required physical and mechanical properties, available technological resources, and cost considerations. And through it all, you must never lose focus of your destination. The winners in the 2017 PM Design Excellence Awards competition, sponsored by the Metal Powder Industries Federation, have successfully negotiated this difficult endeavor. Starting from their confident position of proven experience, they clearly envision the narrow path to get to a novel solution. They embraced the risk involved in taking the first step over the abyss because of the potential reward. They achieved a balance among all the competing considerations, and they kept their focus firmly on the objective, to demonstrate the inexhaustible well of capabilities PM can marshal in the service of component design. In the process, they've created new opportunities for their technology, establishing a new premise upon which they can stand before walking the tightrope the next time. Ladies and gentlemen, at this time, we proudly present to you the winners in this year's competition. 8 grand prizes and 10 awards of distinction have been given. We'll begin with the awards of distinction. An award of distinction in the automotive transmission category has been given to Stackpole International, Canada, for a sinter-brazed planetary carrier made for ZF Germany. The assembly, consisting of a guide plate and a spider, goes into a new 9-speed automotive transmission. The spider is made of a modified FCO208 using 1 level of top tooling, 2 levels of bottom tooling, and 2 separate core rod sets. The guide plate, made of modified FX1008, is compacted using 1 level of upper tooling, 2 levels of lower tooling, and 3 separate core rods. The 4 segments of spline are formed by 4 independent tooling elements. The dimensional control of the net-formed splines was one of the toughest challenges of the product through the compacting, sintering, and induction hardening operations. The PM design solution for a lightweight carrier met all the customer's design and durability requirements, helping the transmission provide a 12 to 16% fuel economy improvement, all the while delivering an estimated 20 to 30% cost savings over alternative manufacturing technologies. Another award of distinction in the automotive transmission category goes to Keystone Powdered Metal Company for an oil pump drive sprocket made of pre-alloyed steel and fabricated for Linamar Corporation, Canada. The part is used in a new 10-speed automatic transmission that goes into the Ford F-150 truck. The 2-level part is made Netshape on the gear teeth and complex ID with its 4 radii flats. Achieving this required not only great precision in the tooling, but also tight process control for weight and density. Only the sprocket's counterbore and datum face require machining. By eliminating the grinding operation on the teeth that would normally be required to meet the gear profile tolerances, the original PM design part produced cost savings estimated at 50%. The part passed extensive durability testing, with particular emphasis on noise, vibration, and harshness, or NVH requirements, so critical in automatic transmissions. The final award of distinction in the automotive transmission category has been won by Burgess Norton Manufacturing Company, Incorporated, for a sinter-hardened steel pocket plate made for Means Industries, Incorporated. The part is a major component of a controllable clutch, a new design for multi-speed transmissions. Removal of clutch packs enabled by the controllable clutch design makes possible smaller 9 and 10-speed transmissions, which helps the automobiles that use them achieve better fuel efficiency. The pocket plate is compacted on a 1,600-ton CNC hydraulic press using 4 lower levels and 1 upper level, and features this net-formed through window on the OD. Robotics and a sensor suite are utilized for deburring this window feature in the green state. Secondary operations include interrupted hard turning with a unique undercut feature, which required the development of a specialized insert, as well as brushing and washing. The award of distinction in the automotive engine category was given to Netshape Technologies for a copper steel duplex cam sprocket made for U.S. Tsubaki. The part goes into the 4.4-liter Big Lion diesel engine in Land Rover's flagship vehicle, said to outperform any SUV on the road. The sprocket is formed on a 1,000-ton CNC hydraulic press using 2 upper and 6 lower punches, requiring excellent control of powder transfer. The part's large size and thin walls, as well as the dome shape and features, make it more complex than is typically seen in many engine sprockets. All the multi-level features are formed net shape, requiring only minimal finish machining on the counterbore, bore, and faces, in addition to a high-end turning operation of the groove to make it a dual sprocket. An original PM design, the part offers an estimated 30% savings over the cost of machining it from wrought. The award of distinction in the Automotive Chassis category goes to Indo-MIM Private Limited for a MIM 4605 low-alloy steel top plate and check shim stop made for its customer, Multimatic Dynamic Suspensions Canada. The mating parts go into shock absorbers on the Chevrolet Camaro sports car. The complexity of the top plate, with 30 oblong slots, 5 thin ribs connecting to a ring around a center hole, and varying thickness, posed a challenge to complete filling of the mold. An especially designed insert ejection system was needed for the check shim stop to avoid producing ejection marks. Both parts are produced close to net shape, with just one turning operation required on each. In replacing a machined part, the MIM design provided increased repeatability and accuracy, providing an estimated 25% cost savings. Annual production is 30,000 pieces and increasing. The award of distinction in the Lawn and Garden Off-Highway category has been given to FMS Corporation for a sinter-hardened steel pivot shift fork made for Team Industries. The part goes into a shifting mechanism in an all-terrain vehicle transmission. The 2 sets of journals are an absolute requirement as they enable the fork to pivot, which is its very function. In the alternative fabrication process considered, a machined and ground stamping, assembled via welding with a pin, the journals represented a substantial cost. Careful engineering analysis by the PM fabricator determined that only a portion of the journal radius was required for proper functioning, and this could be achieved via a face form on the punch face. The estimated cost savings of this PM solution are 40%. The 0.015-inch flatness requirement, as well as the fatigue properties on the interface between journals and body because of their length, made this part design highly risky but ultimately very successful. An award of distinction in the Aerospace Military category was earned by ARC Group Worldwide for a MIM 4140 low-alloy steel latch made for Sig Sauer Incorporated. The internal latch drives a subassembly for the telescoping feature of the collapsible stock on MCX and MPX rifles. Both the diameter and perpendicularity of the through hole in relation to the profile of the slot at the other end are critical for functionality. Those features, as well as the overall length of the latch, make this a challenging part to mold with no distortion in the finished product. The part is sintered near net shape, requiring only a reaming operation to achieve the tight plus or minus 0.001-inch tolerance on the through hole, in addition to several other minimal secondary operations. The part was designed for metal injection molding, as it could not be economically made using any other fabrication method. An award of distinction in the Hand Tools Recreation category goes to Indo-MIM Private Limited for a set of metal injection molded parts, barrel block, gas block, bolt catch, 7.62 NATO mag conversion bar, ejector retainer, and extractor link that go into an MDR rifle made by Desertec. The barrel block, bolt catch, and extractor link are made of heat-treated MIM 4140 low-alloy steel, while the remaining parts are made of age-hardened 17.4 pH stainless steel. The barrel block requires grinding, ID boring, and thread chasing operations, while the gas block requires only an ID milling operation. The rest of the parts are produced net shape with no secondaries needed. The MIM design parts replaced ones that were machined, with some having to be brazed together to form larger parts. In the process, the MIM parts reduced the cost by 30%, while manufacturing lead time was cut in half. An award of distinction in the hardware appliance category goes to ASCO Sintering Company for a copper-infiltrated steel bolt used in a commercial door lock system. The part's complexity, with its 9 levels, rivals that which is more typically seen in parts produced via MIM. However, it is conventionally formed, compacted using 2 upper and 2 lower punches and a shelf die, with multiple levels being incorporated in all of the tooling members and die shelves. Significant powder transfer and fill compensation is used to achieve the shape. The bolt is pressed and sintered to its final shape without any secondary operations. It is estimated to save 60% over the cost of other manufacturing methods. An award of distinction in the Industrial Motors, Controls and Hydraulics category goes to Capstan for a copper steel clutch piston. The part is used in an industrial power takeoff system, a relatively new development for PM pistons. It is a multi-level compacted part that, combined with multiple secondary processing steps, yields a highly precise, machined and sealed PM component, an economically attractive alternative to a machined die-cast one. After molding and sintering, the part is resin sealed to prevent oil seepage, deburred, and then CNC machined to achieve extremely tight diameter, runout, and flatness tolerances, which are held within 30 to 50 microns. This component is a prime example of how innovative machining techniques performed on precise, near-net as sintered blanks can add great value and open up new markets for the PM industry. Ladies and gentlemen, these are the winners of awards of distinction in the 2017 PM Design Excellence Awards competition. Please join with us in congratulating representatives of the winning companies as we invite them to come up to the stage to receive their awards.